Okay. Welcome to my talk about Token Engineering Academy and Token Engineering research groups. Some words about TE Academy. I'm Angela Kreitenweis. I've kicked off the Academy 1 year ago in July 2020, and since then we've had more than 650 participants in our training programs. We have participants from 21 different time zones. We run open science collaborations with Gitcoin, Balancer, Block Science, Hydra DX, Boson, Ocean Protocol, and 96% would definitely recommend our program to others. Again, Token Engineering Academy offers education for token engineers. We are establishing this new discipline and form the body of knowledge, the tools and the ethics. And TE Commons, the community behind TE Academy, is forming this as a new social institution in a community-driven way. Our mission, we develop a new engineering discipline, which is basically the youngest discipline after software engineering was established in the 1960s. We educate a new generation of engineers and redefine the value flows for education and research, since we can leverage web-free value flows for our own offerings and for our own education program. Some words about token engineering. It's an emerging discipline, as mentioned. Let's take a look at crypto. 2008, we had the white paper published, Proof of Work Bitcoin, and 2012, Peercoin, the first proof of stake. Then 2015, Ethereum launched. 2015, also the ERC token standard was initiated. Then 2017, Bonding Curve was launched at Bancor. 2018, Filecoin, this huge ICO with more than 250 millions. And 2021, DeFi with around 60 billion in token value locked. So this is the history, 13 years of crypto. Now look at token engineering. Basically, this discipline was first mentioned in 2018 only, 3 years ago. We were running first meetups in the community, 2018. 2019, academia picked up with first conferences and a journal, and 2020, again, TE Academy launched. So this is really something very new. What's important is that this new discipline can draw from a lot of existing scientific disciplines. And that's good, actually, because we don't have to invent everything from scratch. Let's take a look at this overview. This was from a paper, Foundations of Cryptoeconomic Systems, by Sherman Foshengier and Michael Sargem, published in 2019. And here you can see the various disciplines that are relevant for token engineering. Computer science and cryptography, obviously. Then we can apply AI, optimization and control theory to the design of these systems, industrial systems engineering, operations, research and management science, and of course economics and game theory. And we have the social layer, since in these systems it's not only about technology, it's about the human in the loop. We have psychology, decision science, political science and governance for decentralized decision making, and philosophy, law and ethics as well. Here's a brief overview on a typical token engineering process to give you a flavor of how token engineering works. You start with the ecosystem design, so you analyze who are the stakeholders in your system. So what assets do they bring to the table? What's their motivation to take part? And then you design these economic mechanisms and create a dynamic model, so how this system emerges and changes over time, and the economic model, the value flows, the financial model. And then you not go straight to implementation, you build simulations to stress test and verify your design to see where it breaks, where you have sensitivities. And since we have so many interconnectedness, composability in crypto, this is even more important to detect negative side effects. So you build a digital twin and run simulations and verification of your system, and only then go to implementation and run your system in production. And of course, since we have a digital system, we can collect really granular data on what's going on in this system, as token also being the signal to provide information on your system state, and we can feed back in operational live data into our simulations for further iterations, for system updates, and the strategy of the system. Now let's take a look. I've mentioned this is multidisciplinary. Let's take a look at the students. I've mentioned more than 650 students so far, and here's their fields of study. We have, of course, a huge portion people coming from engineering and computer science. That's great. Also the red one, finance, economics, and business. And in green, natural science, mathematics, physics, and data science. This is pretty relevant. And you can imagine those people are hard to get. They have brilliant job opportunities in traditional finance and Web 2, and it's super important that we can attract them to crypto. And I think we can, because designing crypto economic systems is really an exciting challenge. And then in yellow, social science. As mentioned, we are talking about socio-technical systems, political science, sociology, law, and also design. So this is the combination of students. And our students are coming from all across the globe. So we had in one program 21 time zones, and people are really eager to take part. Sometimes we have teams that are attending lectures during their local nighttime, and not only once, over weeks. So this is really exciting to see. Now here's some screenshots of our recent sessions to give you an impression of how token engineering work looks like, and also how token engineers look like. So this is about programming, diagramming, designing flows of value, also analyzing algorithms. This is our crowd. And now I'd like to take you on a journey to one research group initiative. This is Gitcoin Grants Quadratic Funding, and we worked on it earlier this year and invited community researchers to work on it together with Gitcoin and block science, and work on a particular challenge. First, some words about Gitcoin. You probably all know it, a platform to fund open source projects, and it's actually really successful. In round 10 that closed in July, they distributed more than $1 million in crowdfunding and $700,000 in an additional matching pot. So this is really relevant for open source projects. Now, we worked with Gitcoin and block science to work on a particular challenge for the funding mechanism, quadratic funding. And the challenge was fight collusion and sybil attacks for Gitcoin grants. Now let's take first a look at how quadratic funding works. Basically, we have two different funding streams. Number one, community contributors. So people like you and me, we send from our personal wallets, we send funds to our favorite project via the Gitcoin grants platform and support it. Second, there's a matching pot set up by larger donors, crypto projects that want to support and help the open source layer grow. Now, the funds from this matching pot, again, round 10, around 700K, are distributed according to the support gathered by the community contributors. Now, let's take a look at these diagrams. On the left, in green, we have the community contributions. So you see there are smaller ones, larger ones. Everyone can decide on her own, send $1, send 10, send 50. These are the average numbers. And in yellow, you have the matching pot. And the yellow area is calculated using the values of the green ones. So a square root is taken from the green individual contributions, then you create a sum and end up with this total area and the yellow matching. Okay? Now compare the right distribution of contributions, the left one with the right one. On the right side, we have more green squares and smaller ones. And if you look at the yellow matching funds, then you see if you have many small squares in green, then you end up with a larger total yellow area. So you get more matching funds. And this is actually the key benefit of quadratic funding, because for the matching, the number of contributors matters more than the amount funded. And this reduces the power of whales. If you now imagine, okay, let's take one really big green square there, a whale contributing a lot, then you automatically reduce the yellow area. Okay? This is a benefit of quadratic funding, reducing the power of whales. But it can also be an attack vector, because in theory, a project might activate its community to send a huge number of very, very tiny contributions to your grant. And as a result, we have many, many very tiny green squares and then a massive amount of the yellow area of the matching fund. With only then tiny, tiny little green squares with only a very little own investment. And this is an attack vector to quadratic funding. And our objective was to look through the lens of different disciplines. So we invited community researchers coming from various backgrounds and look through the lens of their own discipline and try to tackle collusion and sybil attacks for Gitcoin grants. Now first, I'd like to show you two approaches applying machine learning to this problem. Danilo defined an optimality gap. This is the difference between the maximum possible matching you can ever get in a certain constellation and the actual matching. This is MR, this is the actual matching, and MO is the maximum possible matching. And this is an optimization problem. So you approximate a global maximum. And one method we tried, you can see it on this tweet on the right, is simulated annealing. And this is an algorithm that's also used for route optimization. You probably know this delivery services, what is the shortest possible route for a number of destinations. And similarly, we asked, what is the maximum matching funds one can achieve with a certain setup of grants and contributions. And such an algorithm takes a lot of iterations of edge rewiring and testing, okay, if I take this combination, is it more? Or can I achieve more matching fund? Or another combination, or another combination. And I think in our hacking session, we had optimization runs that took around 22 hours. So it's computation heavy. However, it's totally viable for a lot of optimization problems. One example. Another approach from a different team was applying node-to-vec, again for detecting collusion. This is semi-supervised learning to find similarities in graphs. So here we represent contributions in nodes, so the contributors and the grants, as you can see on the right, and represent them numerically in a feature embedding, and the algorithm then calculates the similarities between empirical nodes, so what actually happened. This is also a graphical representation of an actual evolution of a donation network. So based on what's actually happening and an injected artificial attack vector, and then compare. Here's an attack vector. Can we find something that looks pretty similar? And this might be a suspicious grant, a colluding grant. Okay, 2 examples, machine learning. Now, another example, mathematics, looking through the lens of mathematics to a token engineering challenge. Andrew, another member of the research group, didn't try to look at the actual contributions, rather to the algorithm itself. So he explored the quadratic funding algorithm and asked if this might be sure convex. So this is there's this sure Ostrovsky criterion, and at first sight, this quadratic funding algorithm isn't, meaning you really have to run optimization runs to find a global maximum. But after a couple of attempts, he proved that actually the sure Ostrovsky criterion can be met, and that means that we can use a very simple, fast calculation to get the global maximum of a certain family of contributors contributing to a grant. And that's actually this is a breakthrough for quadratic funding to make it more robust, because we then are much faster in defining a global maximum. And we don't have to use, for example, one single optimization round takes 22 hours. This is prepared to be a submission to a math journal, so it's an actual formal mathematical proof, and is a major contribution to the quadratic funding literature. Now, these have been 3 examples of tackling collusion algorithmically. However, no algorithm alone is strong enough to really judge on fraudulent behavior. And here I'd like to highlight Block Science's work on establishing a process for Gitcoin grants, define, detect, evaluate, and sanction. You have to first, to fight problems like collusion, you have to define the adversarial behavior. So what is fraudulent behavior in this actual system, quadratic funding? Then you also have to define penalties. You have to detect adversarial behavior, and here we can use both algorithms, as mentioned, as well as human input. Then you can find and flag activity, and then you still have to evaluate, because sometimes organic network evolution looks very similar to collusion. And only then apply penalties and continuously iterate and improve. So here we can see that token engineering is combining human and algorithmic input. And this can also lead to new roles in a system with new rewards for making an ecosystem more robust and resilient. Let me now take you to software infrastructure for token engineering. Here's an example for transparency. Okay, Gitcoin grants, data is open and accessible, its own chain, so everybody has access to it, can see the contributions, can see the grants. However, data analytics is often still a struggle, data analytics on on-chain data. And TJ created a data pouch on tokenomics.io Gitcoin. You can access it still. And to basically find out, hey, what's happening during a funding round and also afterwards. And he found that some of the funds contributed to particular projects are still unclaimed. So here at the lower area, you can see a grant with 21K DAI still unclaimed. So there's also infrastructure needed to analyze grants data or to support the process. And this is a nice example. And last but not least, here's a new framework to integrate existing Solidity smart contracts to token engineering simulations. So our current framework in these disciplines are Python-based. And if we rebuild on-chain interactions, smart contracts in Python, you always have, of course, additional efforts, and it's lacking precision. So Token Spice is a new framework for cases where you want to build your simulation on-chain smart contracts. And one team of TE alumni just got a grant from OceanDAO to further develop this framework and enable token engineers to have Ethereum virtual machine in the loop, basically. So this is what happens if you bring smart people from various disciplines to one room to work on a token engineering challenge. And in case you want to learn more or want to get active yourself, then here are some recommendations. Balancer Simulations, this is a current research group where we are working with Balancer on V2 pools. We have 8 different research projects ranging from dynamic weights to funds of funds strategy. Then we have additional infrastructure provided by the community for the community, JS SDKs and Python models, AMM explorations, a repo to gain AMM intuition, and final presentations again will be next Tuesday. Check out tokenengineering.org, TE Academy, or on Twitter you'll find also all the links. Twitter is Talk Engineering. And here's something where you actually can take part as an active co-researcher. Omnipool Engineering and Simulations is a project that will be kicked off in August and is running until October. And this is a similar research group where we work on cross-chain liquidity pools with Hydra and with block science. And the program includes a really cool onboarding to systems engineering and major paradigms like the mathematical specification of a system, parameter selection, and that we will use CatCat, Python-based framework, and then first part is lectures and introductions, and second part is working on your own personal research question. You can still apply until end of this week. Again, it's via tokenengineering.org, TE Academy, and we welcome people from many different disciplines. Governance is an initiative for establishing a branch of token engineers for governance challenges like votings, like colluding, new Twitter account governance DAO. So follow us if you're interested in this topic. And we'll run first events in August. And finally, TE Commons. TE Commons is the community behind TE Academy to fund and manage the funds for token engineering public goods. And we just kicked off our token launch. The hatch phase opened up last week. Yes, yoo-hoo! lot of TE Commons people here in this room. We have actually more than 400 contributors working on that. And yeah, our goal is to acquire funds and to manage funds for token engineering public goods. So feel free to reach out to everyone wearing such a t-shirt and go to hatchte.commons and be part of it if you think that it's worth investing into ethical, safe, resilient, and sustainable economic systems. Thank you for having me.
Is there any question?
Any questions? You can also ping me. I'm around.
It was too clear.
Okay.
All right.